Hello, welcome to this section on fluid pressure. Do you know what exactly is a fluid pressure? What is its cause? What is absolute pressure, gauge pressure, and vacuum pressure? So, in this session, a fluid pressure will be explained and the remainder. Now, coming to the fluid pressure. So, in order to understand, let us take a closed container filled with fluid. Microscopically, the fluid contains many fluid molecules. These molecules move randomly in the container. When we attach a pressure gauge, the deflections of needle will be observed. This deflection of the needles is due to the collision of fluid molecules on the surface of pressure. So, pressure in a fluid is due to randomly moving molecules in the fluid. Therefore, the pressure in a fluid at any point presents the impact force on the surface due to molecular collisions per unit area. As pressure is indicative of force per area, it is measured in terms of Newton per square meter or. So tell me, when can the fluid pressure is zero? This can happen when there is no collision of molecules. Typically, a region which is called absolute vacuum. Nothing filled within has 0 Pascal. So, do our atmosphere has a pressure? The answer is yes. The atmosphere has a mixture of various gases. Those molecules are performing random motions. At sea level, the mean atmospheric pressure is 101,325 pascals. So, for instance, this is the baseline of 0 pascals, that is 0 pressure. From here, let us mark the line of atmospheric pressure. So, this bar represents atmospheric pressure. Let us talk about one of the day-to-day experience. Most of you might have filled the air of your bike. You measure the pressure by using pressure gauge. When gauge is connected to the bike, you might have observed that the needle gets deflected. Shows you around, for example, 40 psi or 275,790 pascals. When the pressure gauge is disconnected from the tube, it shows you 0 pascals. Why does it show you 0 psi as still there is atmospheric pressure? How can an atmosphere be 0 is the question. Actually, these pressure gauges are designed to read the atmospheric pressure as 0. So, they consider atmosphere as 0. So, 40 psi mean it is higher than atmospheric pressure. So, tube pressure will be 275,790 pascals. From 0 pascals, it is 377,115 pascals. Both values are correct. That is 275,790 pascal and 377,115 pascals. Since they have used different reference lines, tube pressure is equal to 275,790 pascals, that is gauge, and tube pressure, that is 377,115 pascal absolute. One can use any of these two numbers, but one should specify that the pressure is a gauge or absolute pressure. For example, the pressure of water flowing through pipe is say 1000 pascals. This is incomplete information. You must specify that 1000 pascal is a gauge or absolute value or pressure. So, Let us suppose P gauge is equal to 1000 pascals. Then from absolute to 0, what would be the pressure? Therefore, absolute pressure P absolute is equal to nothing but P atmospheric plus P gauge. The P atmosphere, as you know, it is 101,325 plus P gauge in the pipe it is 1000. So total absolute is 102,325. The equation can be used when one wants to convert gauge pressure to absolute pressure. And now let us now understand what is vacuum pressure. For example, a fluid is flowing through the pipe. Suppose the pressure in the pipe is lower than atmospheric pressure. You have attached a vacuum gauge to monitor that pressure. Say that the vacuum gauge shows 1000 pascals. 1000 pascal is the vacuum pressure at that point. Now the question is, what does the 1000 pascal indicates? It shows that the pressure inside the pipe is such that it is 1000 pascals lower than the atmospheric pressure. So vacuum pressure indicates how much pascal in the pressure lower than atmospheric pressure. Then again can be represented with respect to the equation P absolute is equal to P atmospheric minus P vacuum. So that is P absolute is 1,325 pascal. The equation can be used to convert the value of vacuum pressure to absolute. Unlike gauge pressure, vacuum pressure is specifically used for representing pressure which are lower than atmospheric. The beauty of a gauge and vacuum pressure is that you can easily read the fluid pressure from these pressures. They are measured with respect to atmospheric as a reference line. Seen on type of animated content regarding the measure of gauge, atmospheric and vacuum pressures. So this is some of the explain the same in A. Now as was told earlier, the pressure on a fluid is measured in two different systems. So what are those two? One is absolute pressure and another is gauge pressure. So absolute, it is measured above absolute zero or from the complete vacuum. If you consider the pressure, it is called absolute pressure. When the pressure is measured with reference to vacuum pressure, it is absolute vacuum. Now what is another system? Gauge pressure is measured above the atmospheric pressure. We call this a gauge pressure. Generally, this pressure is measured with the help of pressure measuring instruments. We have different types of instruments like Gordon pressure gauge and diaphragm valve. For example, even while measuring pressure in a bike also, we have seen a gauge. Only that gauge is reference to the atmosphere. In that gauge, the atmospheric pressure is termed as zero. Yes, the same thing is atmospheric is taken as data. So the atmospheric on a scale on the instrument is G. Now this is the representation, graphical representation of this two important systems of measurement. One is absolute pressure and gauge pressure. So let for example A is a point where we need to measure the pressure. If with respect to gauge pressure, yes, the reference level is atmospheric pressure. Yes, there is another vacuum pressure where the reference is also the atmospheric, but it is below the reference level. Now, the mathematical representation is the defined as, that is vacuum pressure, is defined as the pressure below atmospheric. Mathematically, absolute pressure is equal to the atmospheric pressure plus gauge S. But if you want to calculate the vacuum pressures, that is atmospheric minus absolute pressure. So for example, atmospheric pressure at sea level, it is 101,325 Newton per square meter or Pascal. So in terms of atmospheric pressure head, it is 10.33 meters of water or 760 mm of mercury. So a problem is given to find out the absolute pressure. Here in this problem, if you see, at 0.3 meters below the free surface is given, so we need to calculate the absolute pressure. Hello, welcome to this new topic on that is measurement of pressure. In the previous sessions, we know how to quantify the pressure. Generally, pressure in a fluid is the force exerted per unit area, maybe Newton per square meter or pascals. Not only that, the pressure can be measured with different reference levels like atmospheric pressure, gauge pressure, vacuum pressure with respect to absolute pressure. Now, to simplify, there are some pressure measuring devices. Yes, maybe manometers or mechanical gauges are widely being used in industry to measure these types of what are manometers. Manometers are generally used to measure pressure at a point in a fluid by balancing a simple column of a fluid by the same or another column of the fluid. There are different types of manometers classified as simple manometers and differential manometers. Another pressure measuring device famous widely being used is mechanical gauges. So these are also devices used for measuring the pressure by balancing the column of the fluid by the spring and dead weight mechanism. So the commonly used the mechanical gauges are Borden tube pressure gauge, diaphragm pressure gauge and bellows pressure gauge. So these pressure gauges are shown in this slide. So all represents or calculates the pressure, maybe with reference to gauge or vacuum with their different operational characteristics. Now we are further narrowing our topic to find the pressure at a point by using only simple manometers. Yes, a simple manometer, it consists of a small glass tube where one end of the tube is connected to point where pressure is to be measured and the other tube remains open to the atmosphere. The diagram we are seeing, if you see, yes, a pipe in which fluid is flowing. For example, consider a session. So the session looks like this. So if we want to know the pressure PA or pressure at this point, simply we can use a manometer, which is a glass tube. One end is fixed to this pipe where pressure of the fluid is required, another is open to atmosphere. So by this we can find out the pressure in a fluid. So in simple manometers also there are three devices. One is a piezometer, U-tube manometer, single column manometer.